everyone, today our group is going to present about cruise control. So what is a cruise control system? Cruise control system is a system that used to control the speed of a car. Usually the system is applied to the closed loop system. So the system is used to sustain a balanced speed of a car. Cruise control is also called as speed control. The importance of the cruise control is to restrain the speed of the car. Besides that, it is used to upgrade the productivity of a car. The input of the cruise control system is the desired speed. The output is the actual speed. The actuator is the engine. Plant is the input of the cruise control system is the desired speed. The output is the actual speed. The actuator is the engine and the plant is the vehicle dynamics. And lastly, the sensor is the speedometer. System which contain of a subsystem of input, output, controller and feedback. This is our block diagram.
Okay, this is our block diagram, which the desired speed is the input. This is the cruise control. This is the engine. This is the vehicle. Actual speed is our output, and this is our feedback, which is the speed meter. Figure 1 shows the simulating windows of the proposed open loop system for the cruise control. The input block is the stat block, taken from the source library. We had to change the value of time to 0 in order to obtain a constant input value of 1 from time. As you guys can see, the figure 1 shows the simulating window of the proposed open loop system for the cruise control. The input block is the stat block, taken from the source library. Okay, and we had to change the value of time to 0 in order to obtain a constant input value of 1 from t equals to 0.
Go.
Then a sum junction is taken from a commonly used library. Okay, the purpose of summing junction is to find the error between the input and output signal using the equation ET equals to RT minus CT, where the ET is the error.
Go.
Okay, the next block is the integrator block, which is taken from the commonly used block from the Simulink library browser.
Go.
The transfer function block is taken from the continuous library.
Go.
Okay, and the last block is the scope, and the sim out is taken from the sim library. That is the scope, and that is the sim out.
Based on the 10 article that we compare in this project, we get we get a few type of controller. First controller, the proportional integrated derivative. Integral derivative, the short we call it PID. The advantage of this PID is improved accuracy and stability of the automobile. So this disadvantage, less control performance for an integrating process, especially for the large time delaying process.
Go.
Okay, the secondly is electronic control unit, ECC. Oh, sorry. This algebraic algorithm controller that advantage to over the traditional derivative that the previous controller. So this disadvantage of the generative algorithm is come from the low off-road wind resistance against the velocity. Okay, next the active cruise controller controller, the advantage is remain safe distance from the preceding vehicle. Okay. Secondly, slow down behind decelerating vehicle, eventually make a full stop, and lastly, slow down and stop behind the stop vehicle. Disadvantage for the active cruise controller is sensor problem and natural disaster effect. Second and finally is suburban road speed lower than 30 seconds. Best controller. The advantage is system when smooth vehicle was a distortion. The disadvantage is hard to detect whether the cruise control is working or not.
Okay, go.
After that, adaptive cruise control system controller. The advantage is upgrade from active that can be performed more than 30 km/h. Disadvantage not capable to stop the vehicle when collision at speed of more than 15 km/h. Then the electronic control unit ECC controller. The advantage is using signal from the control and cancel switch and the speed sensor. Okay, the disadvantage is the driver may not be able to respond as swiftly and effectively to emergency situation. Then the crowd control system controller is the advantage making the best use of the space, available efficient traffic management, and disadvantage is probably to cause highway hypnosis is high. Then adaptive cruise control, advantage spacing error between car. Disadvantage the system have contributed in the past driver losing control on turn or curve in the road. Okay, then adaptive cruise control and eye tracker. The advantage effectively cruise is high speed, minimum speed at 70 m/h. The disadvantage it may lead to the delay braking. The semi-autonomous adaptive cruise control. The advantage is ability to maintain the desired spacing with respect to receding car that has been detected in the lane. The disadvantage is the lack of need maintain constant pedal pressure can increase the risk of vehicle accidents.
I will describe how open loop system in Simulink model. So this is open loop system Simulink in MATLAB that we use in MATLAB software. So this is step that we can find in the library in source. Next is transfer function that we can find transfer function from discrete library. Next is scope. We can find in library which is in SIMS, and same goes to SimUp that generates the workspace.
Okay.
Transfer function that we got from recommended article. So we need to set the transfer function. So this is 2.5 and the others numbers. So this is the transfer function graph that we get from scope that we need to double click in.
For now, I will describe about the closed loop by the Simulink program. Okay, now this is a circuit for the closed loop. The difference from the open loop is there is a summing junction for the feedback. Okay, there's a PID controller that we have to set the PID controller for the KD. Okay, after we click the PID program, then we will see this display will display about the for PID. We set for the KP, KI, and the KD. Then this is a filter coefficient for the tuning. Okay, after the PID, there's an integrator, another one, there's a two integrator. There's a for the KI and the KD. After the integrator, there's a add block. To after the adding, there's a transfer function that we get the transfer function from the before the article before. Then this is the transfer function we set for the system, and this is the scope that we can produce the graph. Okay, there is the graph. There's the two graph. One is the block response and one is the tune response. What is the difference between block and tune is the block is came from the system, but the tune response is the okay, for the tune response is the curve that is made over from the block response.
So I'm going to compare the performance of open loop system and closed loop system in terms of rise time, settling time, peak time, percentage overshoot, and steady state error. Alright, as for open loop system, we are using coding. In order to display and generate the performance of the system. So these are the coding of an open loop system. As you can see, the rise time is 2.36 seconds. The settling time is 4.29 seconds. The overshoot percentage is 0. The peak time is 0.47. And last one, for the steady state error, we will using the formula 1 minus 1 over max amplitude. Therefore, the value of steady state error for open loop system is negative 1.13. Next, this one is for closed loop system. Okay, the parameter, the performance we get from plotted graph. Alright, as you can see, for rise time, the value is 0.71 seconds. The settling time is 2.88 seconds. The percentage of overshoot is 8.42%. The peak time is 1.09. And the steady state error for closed loop system is 0.083 based on the formula that I said just now.
Hi, my name is Yoon.
Hi, my name is Muhammad Amir.
Hi, my name is Habiba.
Hi, I'm Antira.
Hi, my name is Firdaus.
Hi, I'm Amir Ashraf.